a ball of radius r is equal to 10 centimeter rolls without slipping down an inclined plane so that its center moves with a constant acceleration w, that is 2.50 meter per second square, and at t is equal to 2 seconds after the beginning of motion its position corresponds to that shown in the figure. So this is the figure in which this situation is shown. Now what we have to find out? We have to find out the velocities of the points A, B and O. Velocities of these points A, B and O, and also the acceleration of these points A, B and O. Clear? As I have told you in problem 1.52 also, that in order to find the velocity of a given point in such situations of pure rolling, here the object is rolling without slipping, means pure rolling. In such situations the velocity of a given point, the velocity of any point, say point P, is the vector sum of tangential velocity of that given point, tangential velocity of this given point, plus the velocity of the center of mass of the circular symmetric object. So that will be the net velocity or the resultant velocity of that point. And for the acceleration of a given point, the acceleration of the given point is equal to the vector sum of three accelerations. One acceleration is the acceleration of center of mass plus acceleration, radial acceleration or the centripetal acceleration, plus tangential acceleration, and this vector sum of these accelerations is equal to the acceleration of any point in such case of pure rolling. So let's first talk about this point O. Now this is point O. As the body is rolling, so the tangential velocity is in this direction. This is the velocity of the, this is the direction of tangential velocity, and the center of mass is moving towards right. So if I superpose this velocity of center of mass, this is Vc. Now Vc, as it is under pure rolling, is r omega, and as this point O is on the rim of the circular symmetric object, so Vt is also equal to r omega, and hence the net velocity of point O is 0. Velocity of point O is 0. Now if you look at point A, let this is point A. Now the tangential velocity will be in this direction. This is the direction of the tangential velocity, and the velocity of center of mass is also in the same direction. Now Vt has magnitude r omega, and this Vc has also magnitude equal to r omega. So the net velocity of point A is 2r omega. Clear? Or we can write this as twice of Vc. Now as the object is accelerating with this acceleration w, that is 2.50 meter per second square, and we have to find these velocities at this time t, that is 2 seconds. So we can write Vc after time t is equal to 0 plus wt. Clear? So here the velocity of point A after time t is 2wt. W here represents this acceleration, so 2.5 into 2, that is 5. So the velocity of point A after 2 seconds of start is 10 meter per second. Now if you look at this point B, so the velocity of center of mass is in this direction towards right, and the tangential velocity at point B is in this direction. Clear? This is point B. Now as the magnitude of Vt and Vc is same under pure rolling, so that is r omega, this is also equal to r omega, and as these velocities are also perpendicular to each other, so the resultant is in this direction. So the resultant velocity at point B, or the resultant velocity of point B, is under root 2 times the velocity of point C, and we have calculated the velocity of point C as Wt, so it is under root 2 Wt. So the velocity of point B at t is equal to 2 seconds is 5 under root 2 meter per second. So we have calculated the first part, the velocities of all the 3 points A, B and O. Clear? Now in order to calculate part B, we use this equation. For this we need accelerations AC, AR and AT as these 3 points A, B and C. Clear? Now as the system is accelerating with an acceleration W, that is 2.50 meter per second square, this means the velocity of center of mass is not constant, means at different times this velocity of center of mass is different. So from here we can write the velocity of center of mass at any instant, that is equal to r omega. If we differentiate this result with respect to t, we can write dvc by dt, and that is equal to r radius, that is constant, but this omega will change. Now this dvc by dt is the acceleration of center of mass, and that is equal to r d omega by dt, and that is equal to alpha. Clear? And we know that this r alpha is equal to tangential acceleration. Clear? So at a given time in the given situation, this AC is equal to AT. Clear? So at point O, the sum of accelerations, these 3 accelerations, the acceleration of center of mass is in this direction, this is point O, and the direction of tangential acceleration is this, and these 2 accelerations are equal, we have calculated here, so this will cancel out, hence net acceleration along the horizontal or along the ground, or you can see the relative acceleration here with respect to ground is 0, and the only acceleration left, that is the centripetal acceleration or the radial acceleration, and that will act towards the center of the wheel. Clear? So this is also very important result, because many a times in such a situation you will be asked that what is the direction of acceleration at point O when an object that is accelerating and is under pure rolling. So in such a situations you will say that the net acceleration or the acceleration at point O is towards the center of the circular symmetric object. So the acceleration of point O is only the radial acceleration, and that is equal to v square by r, because it is the centripetal acceleration, and v means the tangential velocity, and we have calculated here that vc is equal to vt, so we can write this as vc square by r, and we know that this vc is wt, so this is wt whole square divided by r. W is 2.5, this is 2.5, and t is 2, so this is product is 5, and this is 0.1 meter, so we can write this as 25 divided by 0.1, so this is 250 meter per second square. So we have this acceleration of point O as this much. Clear? Let me check. Okay, here W is 2.50 meter per second square. Okay, actually it is given centimeter per second square, so you will use the results accordingly, so that then it will come out to be 10 centimeter per second. If you choose this centimeter per second square, actually I have done this calculation on the basis of meter per second square, so accordingly you will change. So here again it will come out to be 5√2 centimeter per second, so you can change accordingly. Clear? And here also it comes out to be, so this is 10 centimeter. Clear? So accordingly the answer will be 2.5 centimeter per second square. Clear? Now for point A, the direction of the tangential acceleration and the direction of acceleration of center of mass both are same, and the direction of radial acceleration is this, and we have calculated that this AC and AT both are same, and this AC is equal to W as given in the problem. So the net acceleration of point A is equal to the vector sum of these two. So this is 2 times W square plus the radial acceleration, and this radial acceleration we have calculated this equal to W square T square by R square whole square according to this situation. So if we solve this, we will get 5.6 centimeter per second square. Clear? And similarly for point B, that this is point B, and here the direction of acceleration of center of mass is this, the direction of tangential acceleration is this, and the direction of radial acceleration is this. So from here we can write the net acceleration of point B as the resultant of these vectors. Here AC is in this direction and AR in this direction, so the resultant of this AC and AR is AC minus AR whole square plus AT square. Clear? And from above calculations we know that this AC is W, clear, minus W square T square by R square whole square plus this tangential acceleration, so this is also W and its square. And if we solve this, we will get 2.5 centimeter per second square. Clear? So this is our answer to both the parts A and B, in which we have to calculate the velocities at point A, B and O, and the accelerations at these points A, B and O. Clear? So you have to remember this important result and you will be able to solve this completely.